Pick up a plug and look closely at its two metal prongs. Each one has a small round hole, about 3 millimeters in diameter. The metal removed amounts to just a few square millimeters. The weight lost is less than 1/10 of a gram. That number sounds trivial. 1/10 of a gram of copper is almost impossible to feel in your hand. But when a factory produces 10 million plugs per month, that missing metal begins to matter. Multiply that over a year, and the total reaches hundreds of millions of units. If each plug saves 1 gram of copper, 1 billion plugs equal 100 tons of metal. 100 tons is no longer a minor detail. It's roughly the weight of more than 70 mid-sized cars. Copper is traded globally at thousands of dollars per ton. A tiny reduction in each product can translate into millions of dollars in savings at global scale. And that's only part of the story. The round hole isn't just a subtraction of material. It's also a manufacturing tool, a mechanical anchor point, and a testing aid. It's an intentionally engineered void. In mass production, cost is never calculated per single item. It's evaluated across supply chains that stretch over years. A plug prong is typically made from brass or a copper alloy because these materials conduct electricity well and resist corrosion. Copper has a density of about 96 grams per cubic centimeter, meaning even a small piece the size of a fingertip carries noticeable weight.
Ensure
when
the
engineers
components
remove
match
material
the
without
revised
compromising
cost structure.
structural strength or electrical
Confirmed.
conductivity,
The supply
they
chain data
directly
is
reduce
updated
raw
in
material
real time.
costs. In global supply chains, copper prices fluctuate with commodity markets. A 5–10% price swing can increase production costs by millions of dollars when volumes are high enough.
We've minimized
Removing
the
a
wall
few
thickness
percent
here,
of
cutting
material per
material usage by
unit
10%.
gives
The simulation
manufacturers
confirms that significantly
flexibility
reduces
against
our raw
market
material costs at
volatility.
scale.
Design isn't just about shape, it's a tool for financial risk management. The round hole exists within that economic context. It
composite allows for
reduces
significant weight
metal
reduction without
mass
compromising
without
strength. How does it cost compare with
significantly
traditional aluminum?
It's
weakening
slightly
the
higher, but the
structure.
efficiency gains outweigh it.
Since the section near the tip of the prong doesn't bear substantial mechanical load during insertion, a small void strategically placed through both mechanical and economic calculation. A plug isn't just two metal blades. It's a combination of a conductive core and an insulating plastic housing. The common manufacturing process involves injection molding molten plastic around pre-positioned metal prongs inside a mold. During
Strategic
injection
placement
molding,
balances mechanical
plastic
limitations
may
with
reach
economic
temperatures of
viability,
200–250
ensuring we reach
degrees
the reservoir
Celsius,
through the optimal path
depending on the
for
polymer.
maximum.
The molten material flows around the metal core under high pressure. If the core isn't firmly secured, it can shift by fractions of a millimeter. In electrical components, even small misalignments matter. A slight shift can affect the spacing between prongs, impacting compatibility with standardized outlets. The round hole becomes an ideal anchoring point for positioning pins in the molding machine. A pin passes through the hole, holding the prong firmly in place during injection. Once the plastic cools and solidifies, the pin retracts, leaving behind the familiar round hole. This approach reduces manufacturing tolerances and increases production speed. Fewer misalignments mean fewer defective products in runs of millions of units. Even a 5% reduction in defects represents substantial savings. The hole, therefore, it doesn't just conserve material, it optimizes the production process. Outside the factory, the hole continues to serve a purpose. When technicians need to check voltage quickly, they can hook a probe or alligator clip through the hole, reducing the risk of slipping off a smooth metal surface. In industrial settings, large-scale inspection requires speed and consistency. A stable anchor point improves measurement reliability and reduces errors caused by slippage. At the same time,
The previous cycle
the
time
hole
was
maintains
5.2
compatibility
seconds.
with the retention
Now,
tab
the advanced
mechanism
vortex drill
found in many
increases
North
speed
American
by
outlets.
150.
One small feature fulfills three roles: material reduction, manufacturing stability, and inspection convenience. In engineering, effective solutions often satisfy multiple requirements simultaneously. No additional parts, no extra complexity, just a subtle modification of an existing form. After billions of products have been manufactured with this design, it becomes an unspoken standard, not because consumers demand it, but because entire systems have optimized around it. A tiny
The
round
aperture
hole
performs three
doesn't
functions
attract
simultaneously.
attention
A
when you
high-energy
plug
plasma
in your
conduit,
phone
followed by
charger.
thermal regulation.
But in an industrial context, it represents cost optimization, process control, and quality assurance, all achieved through a single punch operation. Absence isn't always a flaw. In many industrial designs, what's removed carries as much logic as what remains. If such a small detail can handle materials, production, and testing all at once, it's likely that many other objects around you hide similar decisions. The next time you hold a plastic device with a metal core inside, ask yourself what was removed to optimize the whole system. We can continue uncovering other intentional voids in modern design, one object at a time.